Hello, welcome back. In this lesson, we're going to build on the previous tutorial where we learned about the pattern object from Tone.js that allows us to create short, repeating loops of notes. We created a track object using that pattern that allows us to set different pitch offsets, different tempos, different note durations for a small looping musical idea. In this tutorial, we're going to develop on this and we're going to create a fully fledged composition from taking one short loop and then combining it with variations of itself. What we're going to do is very much inspired by an app called Fugue Machine. Fugue Machine by Alexander Knott. This is an app for the iPad and for iPhone as well. And basically what it does is it allows you to write a sequence. Here, let me show you some screenshots. It allows you to enter in a sequence, and then it gives you up to 4 individual playheads through that sequence. Each playhead can apply some modifiers, which means some playheads can have different tempos, right? They can have different pitch transpositions, different styles. So much like our pattern object, they can move forward or forward and back, these kinds of things. And they all play together at once. And what you get is kind of based on this idea of a fugue from classical music. You get this layered composition from a single pattern. So this is a really fun app. I encourage you to check it out if you're curious. We're going to take inspiration from that for this week's example. So what I have here is the sketch we had in the previous lesson where we developed a track class over here. I've remixed it already for this tutorial, and I've also added a bunch of comments in there since the previous lesson, just for your benefit down the road. If you're looking through the code, I've added a little bit more explanations. So this was our class track here. And in the class track, the idea, what we've done is we've created some abstraction around the Tone.js pattern object. The pattern object, just to recap, allows you to loop through an array at a regular interval. In this case, we're looping through an array of indices, and these indices are used to refer to notes inside the sequence array here at the top of the program. So the sequence array is a global variable, which means it's going to be shared by all the tracks that we create. These indices here represent a note index inside the scale array. Here I'm using the C major as our scale, right? C4 major, but we could put in any scale we want, and these note indices just becomes note numbers in the scale. So we've created this track object, and we've given a few parameters to our track here. So we can transpose a track, which means we can shift it up and down in the scale. We can set different note durations. We can set a different tempo. And we can also change the pattern type, which means how is the sequence going to iterate over this this index array, right? Is it just going to go forward or and back, or it can also go randomly and so forth. So let's so this is our current sequence. So I'm transposing here by 1 full octave, right? I'm going back 7 notes in the scale. It's playing on a quarter note. For a quarter note duration, and it's going up and down. So let's change this back to be essentially kind of the base sequence. So we're going to make it 0 transposition, and we're going to have it play just on 8 notes, 8 note, and just up, okay? Which happen to be basically, these are the default values. Okay. So this is playing through this sequence of 4 notes. Okay. Let's add a few more tracks to this so we have something to work with. So for this example, we're going to layer 3 different tracks, and we're going to keep it simple. We're just going to create new variables for these tracks. So we're going to have just track, and then track 2 and track 3. So in initialize audio, we're going to create track 2, and we're going to say, let's make track 2. For example, we can make it the same melody, right? The same sequence of notes without any pitch change, but we could make it have shorter notes, and then maybe happen less often, for example, right? So you can hear now we have the same sequence playing, right? But it's playing at a different rate. With track 3, what we could do is we could create kind of like a baseline, right? So we're going to take track 3, we're going to shift it by 7 notes. That's going to take it a whole octave down. And we're going to make track 3 slower. So we're going to say the note duration is going to be one full bar, okay, or one N, or a full note. And the duration and the tempo are both going to be 1 bar. And then let's see what that would sound like. So you can see now in the background, or you can hear, we have track 3 playing the same note as, what happened there now? Oh, I left this in the key pressed over my sequence for something else. Let's get rid of that. So now we have, one track playing a slightly slower version of the melody, right, from our basic melody, which is really all the defaults. So we could kind of leave all of that blank, really. Then we have track 3, right, which is, it's got our bass line. This is, let's call it like the melody, and then we have the just the bass sequence. Yep. And then lots of interesting things can happen once we start tweaking these. For your code exercise this week, I'm going to want you to spend some time with this, but just so we can experiment here a little bit, we can try different things. So for example, we can make this sequence, faster. And because we're only picking from the same 4 sets of notes here, following the same sequence, there's like some interesting kind of shifting overlap of notes that happen. Another thing that works really well is taking that middle sort of melody track here and shifting it by a certain number of notes. I like to shift by a fifth, which is like 4 notes up in the scale, because that has the most consonants usually with the original notes. So let's see what... Another interesting thing we can do here is, we could change, for example, so the first one here is the note duration. We're going to leave it to be 16 notes, and 16 notes. We're going to go to 8 notes here. So now they're just shorter, but kind of happening at the same time as the bass sequence. And we're going to change the tempo of that middle sort of melodic track to use something called a dotted note. So a dotted note in musical timing is 3/4 of an 8th note. Okay? So a dotted 8th note here is 3/4 of a normal 8th note. So that means we're going to have the middle melody be just a little bit offset from the main melody, and we can make those actually the same note duration if we want. So this one is going to have a little bit of an offset in terms of its timing, and that's going to create some nice polyrhythms. So now there's kind of like a galloping thing happening, and that's because of the 8th note here, the dotted 8 in the middle sequence. And then the interesting thing that we can do also is, we could play with this sequence, come up with some other pattern. We can also change the scale altogether. So because we've made our note sequence just based on note numbers, it doesn't matter what our scale becomes. So for example, we could change from a major to a minor scale, and the same pattern still applies, right? We're just playing different notes now because the scale is different, but the pattern remains. We could create a longer pattern by just adding more notes, for example. So this becomes like a really interesting compositional tool. From a relatively simple element, just a simple seed, just a sequence of note, we can extrapolate a complicated sounding melody that has multiple parts, that has a bass line going underneath it, that's just the same sequence going slower, an octave down, that has a little kind of counterpoint melody thing happening with the dotted tempo, the dotted eighths, and then just our bass sequence that we're hearing. To better try to wrap our heads around what's happening here with our 3 tracks, let's improve our visualization here a little bit, because we're only seeing the notes being played by the first sequence right now. So I kind of like the vibe of this C minor scale over that sequence. Okay, so let's work a little bit on our visualization here for a second. So currently we're drawing the current note being played, and it's pretty large. We're going to make this a little bit smaller for now. All right, so instead of drawing the current note, let's come up with a visualization where maybe we're going to show the whole scale we have to play with, and then we can highlight the notes that are being played by the different tracks. So let's draw the whole scale in a circle pattern. So we're going to write a for loop to do this. We are going to repeat as many times as we have notes in our scale. And then we're going to write some code here that's going to calculate x, y values in a circle pattern. So first we're going to map an angle. So we're going to create, we're going to map the I variable. That's going to be the note in our scale. We're going to map this, so it goes from 0 to scale.length. We're going to map it to an angle between, we're going to start with 0 and 2 pi. So 2 pi is 360 degrees. So we're going to calculate angles going from 0 degrees all the way to 360 all around the circle. And then once we have an angle, to get an x value, let's define a radius too. So radius, let's say it's going to be I don't know, 300. We can tweak that. To find the x coordinate, there's a simple formula we can use that uses the cosine function. So we're going to take the cosine of the angle, and then we're going to multiply that by our radius, and that becomes an x coordinate along a circle. The y coordinate is the same, except we use the sine function for the y coordinate. And that's just some basic trigonometry here. The only thing to remember about this formula is that it gives you coordinates around a circle that has its center at 0, 0. So if we want to draw the notes with the center being in the middle of our screen, we're going to translate the origin to be in the center of the screen first. And then we can use this coordinate to draw something, right? For example, before we put in some notes, I'm just going to draw a little circle here, just so we can see it. So now I've drawn circles, right, at each of the positions where I might want to put in a note. So instead of a circle, we're going to draw the name of the note in the scale. Now, currently in our scale, our notes have an octave attached to them, so we're going to separate that. We're just going to draw the pitch class. So let's say tonal, that's the library that understands the music theory, .note.pitch class, scale bracket I. That's going to be just the name of our note. And we're going to draw it using text at x and y. So here are all the notes of our scale. Now I'm going to move these, I'm going to move these up over here. Perfect. And our current note now is being pushed down there because 0, 0, right, remember, is the center of the screen. So this is our current note being played. These are all the notes in our scale. Just comment this out. So So notice that we're starting at C here because that's where 0 degree lands. It actually is 0 degree is kind of flat like this, horizontal, and this is the C. So in this case, I would kind of like to have the C as at the top here, just for no other reason that it's going to look a little bit more like a clock. So the way we're going to do this is we're going to offset everything by negative 90 degrees. Okay? So we'll say negative pi over 2, and then minus pi over 2. And that just adds a constant offset in our mapping, so that we're mapping from negative pi over 2 to 2 pi minus negative pi over 2. So it just changes the starting point of our circle. Okay. So the next thing I would like to do then is let's highlight the notes that are being played by a particular track. So let's start with track 1. So track 1 has the current note being played here, right? So we're going to say if the note name, so that's the note we're drawing. Yeah? If this is the, actually, let's do this before we draw the text. If the note name is equal to, and then we're going to say again, tonal.note.pitch class, we're going to say track.current note, because we want to get rid of the pitch component. Then let's highlight the note being drawn by drawing a circle around it. Okay. So obviously we need to tweak our sizes here a little bit, and we're going to change the stroke and the fill here in a second. So this is the stroke and the fill for the text. We're going to set a white stroke for the circle and no fill. Let's make this circle a little bit bigger. So now we're highlighting what track 1 is playing. We could also do something nice where if we draw a line from XY to 0, 0, it's going to be a little bit easier to track, which note is being played. Okay, so let's refine this a little bit. So the line is kind of sticking through the circle right now. So to work around this, I'm going to make the circle have a black fill. I'm going to draw the line first. These are just like little visual tweaks here. And I'm going to set the stroke, of course, before I draw the line. Maybe we'll make the text a little bit smaller, 80. Oh, no, actually smaller, maybe 40. Now, if I resize my window here, one of the limitations of my little visualization is it's not aware of the window size. So before I go much further, let's try to tweak that also. So we're going to make these dimensions maybe a little bit more relative to the height of our window, perhaps. Yeah. So let's see. We're going to make let's make a variable for the text size, and we're going to make that relative to the height. So I'm not sure what the height is currently, but let's like divide it by 10, and then let's see what that looks like for our text size. Oh, I probably shouldn't use the same name as the function. That's a bad idea. Okay, so that's too much. I'm just going to use a little bit of trial and error here until I find something that looks right. Divide even more. Okay, so that's about right. So I'm going to divide height by 20 for the text size. The radius, we're also going to make it a factor of the height. A third maybe. Okay, that looks okay. And then the size of the circle here is going to be twice the text size. So if I resize this window up and down, the circle is going to contract now a little bit. So let's use that same idea here to also visualize the other two tracks that we have. So I'm just going to simply here just copy and paste, and we're going to add another if, and we're going to compare now with the current note of track 2. And just so we can tell there's a difference, we're going to change the stroke color. Okay, so maybe we'll make I don't know, track 2 is going to be this color. Don't know what that is. That's not super nice. Kind of like a greenish color here. We can tweak those colors later on. So now we're seeing the two different notes being played. Now one thing that's going to happen is these are going to overlap sometimes, and they're using the same size circle. So maybe what we'll do is we're going to make the bass note, right? We're going to make those come first, and we're going to make that circle just a tiny bit bigger than the next one. So that way, if they overlap, maybe a little bit more. If they overlap, we're going to be able to see when the two circles are overlapping with one another. 2.5. Yeah, that looks kind of cool. All right. And then let's do the same thing again. We're going to copy and paste this, and then this time this is going to be track 3. And track 3 is going to get its own color also. Let's make that one a little bit more bluish. So we can see track 3 is the slow moving one, right? So it's making its way through a pattern. And then for our final effect, we're going to move the background into here. We're also going to remember to put a background in our else statement. And so it's not totally white. And we're going to add just a, the background fading trick by having some alpha. Just to quickly make it a little bit more interesting. It's going to look like, make these lines just fade over time. So what we ended up with here is a simple idea. We're using a generative process to create this melody because we're not writing the composition from scratch. Instead, we're taking a small unit, a small idea, right? This little sequence of 4 notes, and then we're making it work within a system that we created. So we created here 3 different tracks, and then we're letting these tracks play at different times and at different rhythms. And the combination of that sequence being transformed a little bit results in the final composition. Now, the process to make this is generative because we are not directly composing the sequence. Instead, we're applying methods, we're applying a rule-based system to derive the composition. But the outcome is not necessarily generative because every time I play, right, this is going to give me the same song, the same melody. If I change a note in here, I'm gonna get a different pattern, but it's always going to be that same song when I hit refresh. Right? So if I go back to the note that I had, right, it's predictable. In other words, the sequence doesn't change. So the method to generate the song was generative, but the sequence doesn't change. So the outcome is fixed. It's always going to be the same. What we're going to explore in the next lesson is we're going to try to do both. So not only are we going to have this program that we've built so far that has a generative approach to making a composition or a melody, but we're also going to get randomness in how this melody evolves over time. So both the process and the outcome are both going to be generative. And the way we're going to do this is by applying some rules to transform that sequence over time, so that as the music is playing, we're going to be shifting some notes around in that sequence using some randomness, but within a certain set of parameters. So it's not going to be totally random. It's going to slowly drift and shift over time, but still within that framework that we've created. So I'll see you in the next lesson for that.